Good afternoon. This is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic PN junction diode. So in this presentation, I am going to discuss about the basics of diode, symbol, diode operation, biasing in diode, operation of diode in forward bias condition and operation of diode in reverse bias condition, VI characteristics in forward bias as well as a reverse bias. Finally, applications of a diode. So first, what is this diode? So diode is a two-terminal device which allows a current flow only in the forward direction. So this diode is used in the devices which has more sensitive devices, and we have to protect the sensitive devices against a reverse flow of current. So this allows the flow of current only in forward direction and blocks the flow of current in the reverse direction. It is used in the power adapters and even it is used in the LEDs. And this is a symbol for diode. So this diode allows the flow of current in forward direction. So it takes a symbol like a forward arrow. It has a two terminals, positive and negative. Positive terminal is the anode and negative terminal is the cathode. And next is the construction of a diode. So diode consists of two types of semiconducting material. It is a P semiconducting material and the N semiconductor material. The majority charge carriers in a P-type semiconductor material is a holes, and in case of N-type semiconductor material it is a electrons. And we have a junction between this P and N-type semiconductor material, which is a PN junction. And next is a operation of a diode. So when a supply is given to the diode, the electrons in the N layer will move towards the P layer and holes in the P layer will move towards the N layer. So the combination of electron and hole pair takes place, which results in a flow of current. And next is a biasing in diode. What is this biasing? Biasing is nothing but providing the voltage for the devices for its proper functioning. Providing a supply for the device for its proper functioning. There are two types of biasing in case of diodes. They are forward and reverse biasing. This is the forward biasing. In case of forward biasing, we will be connecting the positive of the battery to the anode and the negative of the battery to the cathode. So here force of repulsion will take place. Positive of the battery will repel the holes and negative of the battery will repel the electrons. So we have a diffusion layer between the P and N-type material. So due to this force of repulsion, this diffusion layer will become very narrow. So the electrons from the N-type will move towards the P-type and the holes from P-type will move towards the N-type. So the combination of electrons and holes will take place. It results in a flow of current. So we have a depletion layer between a P-type and N-type. So the depletion layer is initially very narrow and the recombination of electron and hole pair will take place. It results in a flow of current. So we are continuously supplying the forward bias voltage. If the voltage is greater than the barrier potential, then the depletion region will completely disappear. So more electron hole pair will take place. It results in a rapid flow of current. And this is the graphical representation for that. We can use two type of semiconductor material. It can be a germanium or it can be a silicon. For germanium, the barrier potential is 0.3 and for silicon it is 0.7. We are supplying the forward voltage. If the voltage is greater than 0.3 in case of germanium, if it is greater than 0.7 in case of silicon, then the depletion region between the P and N-type layer will completely disappear and results in a formation of more electron and hole pair, so that the current will be increases rapidly. And next is the reverse bias condition. Under reverse bias condition, negative of the battery will be connected to the P-type and positive of the battery will be connected to the n-type. It's a opposite connection. Negative will be connected to positive and the positive will be connected to the negative. Here the force of attraction will take place. Negative of the battery will be attracting the holes and the positive of the battery will be attracting the electrons. So the depletion layer between the p and n type will becomes more widened. So electron hole pair combination will not take place and it results in a flow of no current. And this is in case of the ideal condition. Whereas in case of the practical condition, there is a chance for the flow of very small quantity of current, that too due to the minority charge carriers. And this is the VI characteristics of forward as well as the reverse bias. In case of forward bias, if a voltage is lesser than the barrier voltage, there will be a small gradual increase in the flow of current. Once a voltage is greater than the barrier voltage, there will be a rapid increase in the flow of current. Whereas in case of the reverse bias condition, until the voltage is lesser than the breakdown voltage, there will be a minimal flow of current, that too due to the minority charge carriers. After that, there will be a rapid increase in the current. And finally, the applications of a diode. So diodes are used in the rectifier circuit to convert AC to DC, and it is used in the power supplies. It is used in the places where voltage regulation is required, and it is used for overload protection of a circuit. It is used in the light emitting diode. Light emitting diode and photodiodes are the two types of diodes. LED, it allows a flow of current in forward direction. Photodiode, when light falls on the particular diode, the current is being generated. So this LEDs is used in the displays, and photodiodes is normally used in all medical equipments. It is used in the optical communication. Next is the assessment question. So when forward bias is being done, when the forward bias, in case of forward bias, the positive of the battery will be connected to the anode and the negative of the battery will be connected to cathode. In case of reverse bias, the current flow is very minimal, that too due to the minority charge carriers. This current flow we call it as a reverse saturation current. So when the potential barrier completely disappears, when the applied voltage is greater than the barrier potential. So that's all about the review of PN junction diode. We have discussed about what is a diode and what is a symbol for diode and what is the construction of diode and working principle. Then operation of diode in the forward and reverse bias. Finally about the applications of the diode. Thank you.